The Tonle Sap. The Tonle Sap or Great Lake of Cambodia, forms part of a unique and ecologically significant subsystem within the Mekong Basin. It is the largest freshwater lake in Southeast Asia, covering an area of 250,000 to 300,000 ha during the dry season and up to 1.6 million ha during the wet season, ADB, 2002. Expansion of the lake during the wet season is due primarily to the annual monsoonal flood pulse moving down the Mekong and entering the lake through the Tonle Sap River, which reverses its course as the water level in the Mekong rises above that of the lake. Besides drainage from the Mekong during the monsoonal flood, 13 other catchments drain into the lake. The lake plays an important role in flood peak attenuation and flow control to the Mekong Delta, storing up to 40 cubic kilometers of Mekong floodwater each year and releasing it slowly back into the system, MRC, 2005. It was listed as a UNESCO Biosphere Reserve in 1997, and is designated as a protected area under Cambodian royal decree and through numerous international agreements. By far the largest area of savanna swamp forest and inundated forest in Asia, it contains important Ramsar-listed wetlands, and supports extensive fisheries and agriculture of critical importance to the Cambodian economy. Some 2.9 million people live in the 5 provinces surrounding the lake, ADE, 2002. With economic and political stability returning to the region in the past decade, the population around the margins of the lake is expanding rapidly, along with agricultural activity. Floodplain hydrology and wetland, flooded forest and riparian communities are being modified at a rapid rate and with major ecological impacts. The Tonle Sap Floodplain Study Area. Several ancient Angkorian capitals flourished on the northern margins of the Tonle Sap floodplain between AD 802 and 1431, Chandler, 1996, and the floodplain has been modified in the past. Structures were built to control the movement of water across the floodplain and harvest it for agricultural purposes or to provide sites for aquaculture activities. This resulted in an extensive hydraulic network estimated to cover more than 1,000 square kilometers, Evans et al. 2007. Centralized control under the Angkorian court and highly organized agricultural production across the lowlands around Angkor produced economic surpluses for the state. Construction of reservoirs and channels occurred on a large scale through controlled use of labor, including slaves, Hyam 2001. Although much of this original irrigation and agricultural infrastructure has probably been subsumed into more recent schemes, or obliterated by the flooding cycles of the lake, several examples of the largest ancient structures remain. These include the Domdik Channel, a 200 meters wide channel extending approximately 80 kilometers through the floodplain with 10 to 15 meters high walls, and the Western Baray at Angkor, a water storage covering 17.5 square kilometers. The inflow from the Mekong accounts for approximately 70% of flow into the Tonle Sap Lake, Penny, 2006, with the remainder coming from local catchments. Some 80% of the sediments and nutrients entering the lake from the Mekong are retained, MRC, 2005, and this annual process supports floodplain and fisheries productivity. The Tonle Sap Lake is therefore highly susceptible to changes in the size, timing and duration of the annual monsoonal flood pulse, whether that occurs as a result of climate change or upstream water resources development. The past decade has seen reductions in flood height and flooded area of the lake, Campbell et al. 2006, although 2008 saw larger than normal floods throughout the Mekong. Kiem et al. 2008, in their latest modeling, suggests that precipitation will increase by 4.2% on average throughout the Mekong Basin, concentrated in the upper sections of the basin in China. Chen Bano, 2003, suggests that while there will be some shift in the timing of the flood peak, flooding durations will still be adequate for the survival of significant wetland areas on the Tonle Sap. Most management efforts on the Tonle Sap to date have focused on maintaining the lake's fisheries, which provide up to 70% of the protein intake for the entire Cambodian population, Van Zaling et al. 2000, and protection of the Ramsar wetlands as bird nesting sites. Natural resource management is severely under-resourced and occurs in a piecemeal manner, Bonur and Lane, 2002, in the face of poorly delineated jurisdictions and conflicting economic interests. Despite the importance of the Tonle Sap Lake to the Cambodian economy, only in recent years have authorities and research agencies begun to characterize the flooding cycles of the lake or map floodplain vegetation distributions. Some modeling of lake hydrology was completed in 2003, Koponen et al. 2003, and an Asian Development Bank project is currently underway to produce GIS datasets of lake resources, ABD, 2002. The Cambodian Mekong National River Commission, MNRC, in association with the Multi-Country Mekong River Commission, MRC, now monitor flood conditions in the Mekong and the Tonle Sap, but data is restricted to a limited number of gauging stations and is often not reliable. For example, the nearest MRC gauging station is located at Kampong Chong, on the Tonle Sap tributary.